Questions 21 through 25 of the 1997 grade 10 Cayley math contest is what I will cover in this video. 21 says, if a over c plus a over b plus 1 all over b over a plus b over c plus 1 equals 11, where a, b, and c are positive integers, the number of different ordered triples a, b, c such that a plus 2b plus c is less than or equal to 40 is. So let's take this one step at a time. The first thing, of course, we need to do is work with this right here. And I'll write it out. Got a over c plus a over b plus 1 all over b over a plus b over c plus 1 is equal to 11. So we essentially need to just simplify this as much as we can, and this is just fractions. So it looks like the common denominator is going to be bc. So we'll have to multiply top and bottom here by b, so this would become ab, top and bottom here by c, this becomes ac, and top and bottom here by bc, so this becomes bc. Similarly, the bottom looks like we'll have ac as our common denominator, and top and bottom here by c, so this becomes bc, top and bottom here by a, so this becomes AB, and top and bottom here by AC. So this becomes AC. Bring this over here. Invert and multiply, so AB plus AC plus BC over BC times AC over BC plus AB plus AC is equal to 11. Now the good news here is that this is the same as this, right? AB, AC, and BC. So those cancel. So you're left with just AC over BC. And the C's cancel here, so you're just left with A over B is equal to 11. So we've simplified this big equation into just this one. So that's going to help us. Now, since we have 11 is equal to a over b, and remember a and b and c are positive integers, we have to figure out what possibilities do we have. Well, we can have one possibility, which is a equal to 11 and b equal to 1. If we use these two numbers, a over b will indeed be 11. So let's work with that. Now, what are we trying to figure out in this question? We're trying to figure out this right here. A plus 2b plus c is less than or equal to 40. So a plus 2b plus c is less than or equal to 40. How many values of c do we get? Well, a is 11, b is 1, and c we don't know. So we got 11 plus 2 plus c is less than 40. C is less than 40 minus 13, which is 27. So C is less than 27 in this scenario. So that means C can be 1, 2, 3, 4, all the way up to 27, because we only looking at positive integers. So there's 27 possible values of C. So that means we have 27 triples. We have 11, 1, 1 for A, B, and C, 11, 1, 2 for A, B, and C, all the way down to 11, 1, and 27. Okay? Because that's what the question is asking. We're looking for ordered triples of the form A, B, and C. So now let's keep going here and see if there's any other values we can find. A over B equals 11, so we can also have A equal to 22 and B equal to 2. If we do that, then this becomes A plus 2B plus C is less than 40. Plug in the values. We got 22 plus 4 plus C is less than 40, and therefore C is less than 14. So very similar to over here, C in this scenario can be 1, 2, 3, all the way up to 14. So that gives you an additional 14 ordered triples of the form 22, 2, 1, 22, 2, 3, 2, all the way up to 22, 2, 14 for A, B, and C. Now let's see if we have any more. How about A is equal to 33 and B is equal to 3? That would, of course, satisfy that equation. Now let's see what we get for this equation. A plus 2B plus C is less than 40. So we have 33 plus 6 plus C is less than 40. So C is less than or equal to 1. So in this case, we only have one value. So that's just 33, 3, and 1 as the only ordered triple that we can get in this case. And then if you keep going, A equals 44, B equals 4, what you'll notice is that this cannot be true anymore, because you will no longer get a positive value for C. So this is our limit here. So if you add these up, we have 27 triples from here, you have 14 triples from here, and you have one final triple from there. And that equals 42. And the answer, therefore, is D. In the diagram, ABC is equilateral, BC is 2 times CD, and AF is equal to 6, and DEF is perpendicular to AB. What is the area of quadrilateral FBCE? So FBCE, this quadrilateral, is what they want you to figure out the area of. All right, so the first thing I'm going to do is draw this out a little bit bigger. And let's label this. So we got A up here, this is F, this is a right angle, this is E, this is C, this is D, and this is B. Now let's fill in what the question gave you. AF is 6, so that's 6 over there. And they're telling you that BC is 2 times CD. So if CD is X, BC is going to be 2X. That's what they tell you here. And I believe that's about it. That's all they've given us. So this is what we have to work with. So the first thing, in order to figure out the area of this quadrilateral, we have to figure out first the area of the entire triangle, that triangle right there, and then subtract from it this triangle. And if you do that, you'll get the area of the quadrilateral. So the first step is to figure out the area of the total triangle. So how do we do that? The first thing we're going to do is drop a perpendicular right there. And what that will do is allow us to create a relationship between the sides. Now, since ABC is equilateral, each of these angles is 60. Now, if this is 60 and this is 90, this is going to be 30. Okay? And I'm going to draw over here that 30, 60, 90 triangle. Like that. Now, whenever you have a 30, 60, 90 triangle, and this is going to come up again and again during your math contests, there's a relationship between the sides. The side opposite 30 degrees is 1, not the value necessarily, but the ratio. This is 2, the hypotenuse, and this is root 3. Okay? And that's very important to remember. So in this AB triangle right here, it's essentially a 30, 60, 90 triangle. So if we have this side as x, then this side is going to be 2x, just from this relationship right here. And therefore, this is going to be root 3x. Okay? Remember, this 30, 60, 90 is very important. So now we can figure out the area of the big triangle ABC. It's just 1/2 base times height. The base is right here, which is 2x. And the height is root 3x. So therefore, we have root 3x squared. So that's the first part of the question. Now the next part, of course, is we want to figure out the area of this triangle right here, this small one. And if we can do that, we can subtract it from this and get the area of the quadrilateral. But we don't know any of the sides, so what do we do here? Well, again, similarly, it's a 30, 60, 90 triangle. I'm just going to draw it here so you don't get the diagram too messed up here. So this is 90, this is 6, this is 60 degrees, and this is 30 degrees. So very similar. The ratio of the sides is 1, 2, root 3. And therefore, if this is 6, then this is 12. And therefore, this is going to be 6 root 3, the length of this side. So the area of this small triangle is 1/2 base times height. The base is 6 root 3. And the height is 6. So we have here 18 root 3. Okay? So the area of the quadrilateral, as I previously mentioned, is going to be the area of the full triangle minus the area of the small triangle. So quadrilateral FBCE is root 3x squared minus 18 root 3. But the problem is we've got a variable in there, and we don't want a variable, we want a number answer. So what do? Well, we have to figure out x. And the way you figure out x is go back to our diagram and look at this triangle FBD, this triangle right here. FBD. Okay? You'll notice that this is also a 60, 30, 90 triangle. This is 60, that's 90, it's a right angle, and this is 30. Therefore, the ratio of the sides are going to be similar, 2, 1, and 3. So I drew it again just to avoid making the diagram too messy. So FBD. We have a right triangle there, we have 60 degrees here, and we have 30 degrees there. And from our diagram, we know that this is going to be of the ratio 1, 2, and root 3, because it's a 30, 60, 90 triangle. And therefore, if we can figure out these sides, then we can calculate for x. Now, do we know any of these sides? Well, let's go back and see. Well, this is FB, right, from here to here. And we know that AB was 2x. We previously figured that out. So that means that FB is going to be 2x minus 6, because A to F was 6. So FB is 2x minus 6. So that's going to help us. So using these very valuable ratios, BD is going to be 2 times 2x minus 6. And just for the sake of completion, this side is root 3, 2x minus 6. Okay? We're almost done. So BD is equal to 2 times 2x minus 6. But here's the key to the question. We also know BD is equal to something else, and that is right here. From B to D is 3x. 2x here and x there. So BD is equal to 3x. So I'm going to plug that into our little formula. And this will allow us to calculate the value for x. So this becomes 4x minus 12 is 3x. We've got x is equal to 12. Okay, done. And then the very last step, of course, is to put that value of x into this equation. So it was 12. So that means we have root 3 times 12 squared minus 18 root 3, which is 144 root 3 minus 18 root 3, which is equal to 126 root 3. And let's see if that is one of the answers. And it is. Choice C. Given the set 1, 2, 3, 5, 8, 13, 21, 34, 55, how many integers between 3 and 89 cannot be written as the sum of exactly 2 elements of the set? Okay, so they're just going from 3 all the way up to 89. So 3, 4, 5, 6, 7, 8, 9, 10, and so on. So I'm going to write all these out. So that's the set. And can I make any of these numbers as the sum of 2 elements? So let's start with 89. And the answer is yes, 34 plus 55. So this is something that is a good choice for us. What about 88, 87, 86, and all those? Unfortunately, no. The next time you can possibly get a number that's going to be the sum of 2 elements is when you have 55 added to 21. And that's going to be this one, 76. 21 plus 55. Okay? And then similarly, if you keep going like that, you'll see that the next one is 55 plus 13, which is 68. And then the next one, of course, would be 55 plus 8, which is 63. And then you just keep going like that. The next one is going to be 55 plus 5, which is 60. And then 55 plus 3, which is 58. And then, of course, 55 plus 2, which is 57. And finally, 55 plus 1. So when you're adding 55, how many did we get? We got 1, 2, 3, 4, 5, 6, 7, 8. So for 55, we got 8 possible numbers that we could create with the sum of two numbers in this set. Now let's go to 34 and see what happens. Well, the biggest one, of course, is 34 plus 55. We already got that, so that doesn't count. We can't count it again. But what about 34 plus 21? 34 plus 21 is definitely something that we can use, and that is 55. And of course, you just keep doing that. 34 plus 13, 34 plus 8, and then we're going to have to move up a little bit. 34 plus 5, which is 39. And then 34 and 3, which is 37. 34 and 2, which is 36. And finally 34 and 1, which is 35. So how many do we get for 34? We got 1 here, 2, 3, 4, 5, 6, 7. So we got 7. And if you keep doing this, I'll leave it up to you. You'll see that for each one, you'll get 1 less. You get 6 possibilities with the 21. It'll be 21 plus 13, 21 plus 8, 21 plus 5, 21 plus 3, 21 plus 2, and 21 plus 1. You'll get 5 possibilities for the 13, 4 for that, which is 8 plus 5, 8 plus 3, 8 plus 2, 8 plus 1, 3 for that, 2 for that, 1, and we'll basically have exhausted it by the time we get down to 1. There's no more original ones left. So the total is the addition of this, 1 plus 2 plus 3, which is equal to 36. Now these are the ones that are possible to create by the sum of 2 of these elements. Now that's not what the question was asking. This question was asking how many cannot be written. So all we have to do is subtract how many can be written from the total. Well, what's the total? Well, we have numbers from 3 to 89. So that's 87 numbers. 36 of them can be written as the sum of 2 elements of the set. So the number that cannot be written as the sum of 2 elements of the set is 87 minus 36, which is equal to 51. So the answer for this will be A. In a convex polygon, exactly 5 of the interior angles are obtuse. The largest possible number of sides for this polygon is... Well, first of all, let's do a little bit of a review. When they say obtuse, what do they mean? Well, obtuse is basically any angle that's between 180 and 90. This is the symbol for angle, or at least the symbol I use. And then you have obtuse angles and you have acute angles. Acute angles are basically angles that are between 90 and 0. Okay? So they're saying in this polygon, this shape, exactly 5 of their angles that are interior are obtuse. Okay. So let's say it has n sides, this polygon. We don't know what n is. N is what we're trying to figure out. That means exactly 5 are obtuse. 5 angles. Okay? And I'll call them alpha 1, alpha 2, alpha 3, alpha 4, alpha 5. Okay? Therefore, all the remaining angles are acute. So of the n, 5 are obtuse, so n minus 5, the remaining, are acute. So I'll call that A1, A2, A3, all the way up to, we don't know what n is, so it just keeps on going. A certain amount of angles. Now, one very important thing you need to remember is that if a polygon has n sides, the sum of all its angles are equal to n minus 2 times 180. That's just a standard rule. So we can further simplify this as 180 times n minus 360. Okay? So now we have these angles that I have labeled with this alpha symbol as obtuse. So each of these is between 180 and 90. That's what obtuse means. So since we have 5 of them, we've got alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5. If we keep this equality situation, we have to multiply both sides by 5. So they've got to be greater than 5 times 90, and they have to be less than 5 times 180. So that means that alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5 has got to be greater than 450, but it's got to be less than 900. Those are the extreme ranges of the sum of these angles. And very similarly, we do the same thing for the acute angles. The acute angle, one acute angle is between 90 and 0. But we have, how many? We have n minus 5. So we're going to multiply everything by n minus 5. So all of these, A1, A2, A3, dot, 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 we don't know how many there are, is less than n minus 5 times 90. So this just becomes 0, is less than 90n minus 450. Okay? So I'll call this 1, and I'll call this relationship 2. If you combine 1 and 2, you get the following. 450 is less than alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5 plus A1 plus A2 plus A3, essentially all of them, all the angles, is less than 900 plus 90n minus 450. So this just becomes 90n plus 450, like that. Now, what is the middle part here? These are all the angles of this polygon. And remember, sum of all the angles is equal to 180n minus 360. So we can substitute that in. 180n minus 360. And this is less than 90n plus 450, like that. And we're almost done here. We just have to solve this final inequality or equality. So if we put the n's on one side, we get 90n is less than 810. And if we solve this, we get n is less than 9. So if n is less than 9, the maximum n can be is 8. So the maximum number of sides is 8. And therefore, the answer is B. In triangle ABC, BR is equal to RC, CS is equal to 3 times SA, AT over TB is equal to PQ. If the area of RST, right here, is twice the area of TBR, which is right here, then P over Q is equal to. Okay, I'll draw this triangle a little bigger, and we'll label these sides here. We've got A, we've got S, T, R, C, and B. Now, CRS is this triangle right here, and CRA is this triangle right here. So I'm going to draw a line from A to R. Now, it's a very important relationship that you need to understand throughout this question, because this is going to come up again and again when we compare triangles, is that the height is going to dictate the relationship. So for example, if you look at CRA, this triangle right here, right? What is the height? Well, we drop a perpendicular like that and we can call it H. Let's call it H1. Now, if you look at CRS, which is essentially this triangle, it also has the same height. Okay? So if it has the same height, we can compare the sides, and therefore we get a relationship for the areas. So CRS, the area is 1/2 base times height, which is H1, and CRA is 1/2 base times height, which is also H1. Just get the base of CRS, which is CS, over the base of CRA, which is AC. Well, how does this help us? Well, this is where this comes in. So let's say SA is B. So if CS equals 3SA, let SA equal some variable like B, and therefore SA is B, and therefore CS is 3B. So CS is 3B, AC is the whole side, which is 4B, and therefore you get 3 over 4. So you see how we did that? We used the sides to essentially create a relationship between two of the triangles. And we've got to do this several times. So here we go again. So the next triangles we have to compare are CRA and ABR. So CRA is basically here. CRA, and ABR is right here. So similarly, you have to draw a perpendicular like that, and you can call that H2, and therefore this will be 1/2 base, which is CR, times H2 over 1/2 base of ABR, which is BR, times H2. But recall, the question tells you that BR is equal to RC. So BR, if we let it equal A, RC will equal A. So therefore this is A H2 over 1/2 BR, which is A times H2. So this is just 1. So now we're going to compare triangle CRS to triangle CRA again, and we figured that out already, which is 3 over 4 at the top there. So this is 3 over 4. And if you notice, CRA, which is this triangle right here, is essentially half of the total ABC, because this is A and this is A. So therefore, we can put CRA as half of ABC. Like that. Now ABC, unfortunately, we don't know. So we're just going to let ABC equal X. So that means that CRS, triangle CRS, is 3/4 times 1/2 X, which is essentially 3 over 8X. Okay, so all of these things will come into play later on. So to avoid making the diagram too messy, I'm going to draw this triangle again. A, C, R, B, T, S. And recall the question tells us that AT over TB, AT over TB is equal to P over Q. So that's important. So AT over TB is P over Q, like that. So now we're going to compare triangles TBR to triangle ABR. So TBR is this one right here, and ABR is right here. So we have, again, if you drop a perpendicular like that, and you can call that, say, H3, TBR is 1/2 base times height, which is 1/2 TB times H3, and ABR is 1/2 base times height, which is AB times H3. So the halves and the H3s cancel out. TB is Q, and AB is P plus Q. Okay? Now, ABR, this one right here, is right here, ABR. And that, if you notice, is just half of the total triangle, because this, if you recall, were equal. So this becomes TBR is equal to half of ABC. And we called ABC X. So this will basically be X over 2 is equal to Q over P plus Q. And then finally, we've got one last one, which is ATS compared to ATC. So ATS is right here, and ATC is this one right here. And similarly, we'll drop a perpendicular from this point to this point, and representing that as the height is, say, H4. So ATS is 1/2 base, which is AS, times height, H4, and ATC is 1/2 base, which is AC, times H4. So the halves and the H4s cancel, and AS, if you remember, if we go back, was B, and this whole side was 4B. So this was B, and this was 3B. So this whole side was 4B. So AS is B, AC is 4B. So we've got a relationship of 1/4. So therefore ATS is equal to 1/4 of ATC, and ATC, which is basically from here to here to here, is basically a proportion of the full triangle. If you use P and Q, it's basically P over P plus Q times X, where X represents the full triangle ABC. And now we have pretty much all we need. Let's write out our findings. We've got ABC, which we let equal to X. We've got CRS, which we found at the very beginning up here, 3/8 X. We've got TBR, which is here, which was essentially equal to QP plus Q times X over 2. And we've got ATS, which is 1/4 P plus Q X. And we have to figure out the relationship between the final two triangles. And those final two triangles they've given right here. RST is equal to twice the area of TBR. So RST is equal to twice the area of TBR. So RST is equal to twice TBR. So let's fill all this in and we'll be able to solve this. TBR is right here. Q over P plus Q times X over 2. Now what's RST? RST, if you look at this, is equal to the full ABC, right? Minus these three smaller triangles. So minus CRS minus TBR minus ATS. And we've got all of these, so we can put them in. If you recall, it was ABC minus CRS minus TBR minus ATS. ABC is right here, it's X. CRS is right here, it's 3/8 X. TBR is here, we've got Q plus P plus Q over X over 2. And finally ATS we've got here 1/4 P over P plus Q times X is equal to Q over P plus Q times X. These twos cancel out. Now there's an X everywhere, so X cancel. So this becomes 1 minus 3/8 minus Q over P plus Q times 1/2 minus P over P plus Q times 1/4 equals Q over P plus Q. So now we've got to do some algebra here. So we've got 5/8 is equal to, looks like there's a common denominator of p plus q, so that helps. We've got q from here. You've got plus q over a half, this one, plus p and a quarter from this one. So we got 5/8 is equal to 3/2q plus p/4 is p plus q, and then we'll cross multiply like that. 3/2q plus p/4. So we have 5p plus 5q is equal to, this looks like 12q and 2p. So we have 7q is equal to 3p, and therefore p/q is 7/3. This is what they were asking, p/q. If you go back to the very beginning of the question, they were asking for p/q is equal to, and we got 7/3, so the answer is E.